All right, folks, very warm welcome to the first session of the evening. It's evening here in India, and a very warm welcome to Michele and Francesco, amazing speakers from Accenture. We have had them before in our chaos engineering meetup, and it's great to see them again to talk about chaos engineering meets AIOps. So, ladies and gentlemen, a very warm welcome. Please meet Michele Dodič. He is an SRE DevOps specialist at Accenture, and Francesco, he's leading the SRE Tech ASG at Accenture once again. And I would allow, without any further ado, I'd allow them to take on the floor, share their screen, introduce themselves, and enjoy this amazing talk.
Thank you, Prithvi. Okay, hello to everyone. Welcome to our session on Chaos Engineering meets AI Ops. My name is Michele Dodič. I have a background in software engineering, AI, and industrial automation. I specialize in several SRE-related topics such as AI Ops, observability, and chaos engineering. I'll give a word now shortly to Francesco.
Hi, thank you very much, Michele. So I'm working at SRE and AIOps tech lead at Accenture. I have around 20 years of experience of solving problems in production, in corporate startups and governments. And furthermore, I have a deep experience in automation, observability, and chaos engineering. And I'm currently growing the capability of SRE and chaos engineering at Accenture. Back to you, Michele, for the agenda for today.
Thanks. So I suggest we crack on and take a look at what we have lined up for today. So I'm going to start by defining the basic concepts surrounding observability, which is an important prerequisite to what we want to achieve today. After which we'll tackle the main concepts of today's session, which are obviously AI Ops and chaos engineering, and we'll take a deeper look at how these two are connected. We will follow up by a custom demo that we have prepared, and the purpose of this demo is to put in action all of the concepts that you see here and that we will talk about, after which we'll wrap up with the key takeaways. But let's first start with the whys. So, as I already mentioned, our footprint is site reliability engineering. So it's only natural for us to frame everything from an SRE perspective. So the question here is, why site reliability engineers need AI Ops? Why do they need chaos engineering? So the diagram that you're seeing here, I'm using it just to illustrate where these concepts fit from a high-level perspective. As SREs, we always aim to save time so we don't have to do things manually, which inherently improves all of the relevant KPIs, talking about MTTD, MTTR, or any other MTTX, just as an example. Furthermore, we aim to establish end-to-end insights with the purpose to reduce toil, which is what we see on this slide. And in order to do that, we need to take a closer look into AI Ops as well as chaos engineering platforms. So AI Ops and chaos engineering are generally concepts which are kept separate. However, the aim of this session is to find where these two meet and how we can best make use of them. Speaking of chaos engineering, there are several steps one needs to undertake beforehand. Here we see various prerequisites necessary to realize the full benefits of chaos engineering, of chaos experiments in general. I won't go through all of them, as this session is not a deep dive into chaos engineering, but rather its application combined with AI. However, a prerequisite which I deem most important for this session is definitely observability. And before we put AI Ops into play, we need to make our system observable. Okay, so now this is a good time to introduce observability itself, as well as another important concept, which is open telemetry. So the focus of observability is to introduce transparency and visibility across our entire end-to-end system. This, for instance, means understanding how the various components in our system are connected to each other. What are their dependencies, for instance? Because our ultimate goal is to derive actionable insights. So here we see a couple of notions relevant for observability. We have different sources of data illustrated in the center figure that we need to observe. And moreover, observability is the ability to measure a system's current state based on the data that it generates, such as logs, metrics, traces, which is the so-called golden triangle of observability, which is on the left-hand side. While on the right-hand side, we see the golden signals, which consist of latency, traffic, error, and saturation. When we conduct a chaos experiment, we usually play with one of these dimensions. For example, we introduce latency into our system to test how our AIOps solution reacts, but we'll talk about this a bit more later. Okay, before we move on to the AI side of things, it's also important to understand how we collect all of this data that we just mentioned. What we are using is OpenTelemetry, which is an open source standard for generating and capturing what we see here, traces, metrics, logs, so basically our golden triangle. And on the right-hand side, we can see a diagram illustrating how OpenTelemetry exactly works. So starting from the top, we have logs, traces, and metrics that are generated. But if you see, we're also talking about raw data too. This data is then collected by the OpenTelemetry collector, which enriches and processes it. And in fact, this enrichment process occurs in completely uniform manner for all three signals. The resulting output produced by the collector is, as you can see, the correlation of our golden signals, whether by time of execution, execution context, or resource context. All of this is then forwarded to our backend. And I introduce this specific context talking about OpenTelemetry as it is relevant to the demo that we will be showing a bit later. Okay, Francesco, I'll give the word to you to introduce AIOps.
Thank you very much, Michele. We can go next slide. Okay, we start with what is AIOps. So why do we need AIOps? We already covered it. So now we are trying to understand what is. And as Michele was mentioning before, so we use observability to collect a lot of metrics, a lot of data coming like from systems, from application, and traces, and as well logs at the end. And you can imagine that here what we see on the left side of this picture is about historical data. So we don't need just on the real time, but we need also what was happening before. Why do we need this? We will cover later. Then on the second part, you can imagine that you have also the real time in the meantime coming inside the system and the platform. So what do we use at the end to kind of try to understand if there is a problem at the end, and also to react to this problem? So we use machine learning. There are different algorithms or models that we can use to kind of discover what you see on the small picture here. So we can do the historical data analysis. We can try to find pattern, for example. We can try to find the classical black swan. You can try to find and remove noise. So you can imagine that something was already happening in the past, but was so small, so was not creating a real incident. And now what we use is machine learning to try to understand faster than us if there is a problem, and also maybe to predict later. The anomaly detection is really important because it's a part of the SRE. So we need to try to understand if there is an anomaly. And in this case, we will see that also the chaos engineering part is at the end introducing failures and anomaly inside our system, proactively, of course. We have a performance analysis. And then last one is the correlation and contextualization. Why do we need the correlation at the end? So correlation is really important for us because maybe there is a problem that is happening somewhere else in the application or on the system, and this is affecting, is kind of interfering with our application in the end. So we can have a cascade, and we will see also later in the demo from Michele about the microservice. You can go in the next, Michele. Next slide, please.
Yeah, I'm on the next slide, unless there's a bit of delay.
Not yet.
Okay.
Now, okay, and here what we see is what we can do with AIOps. So as we mentioned before, it's not only about analysis or using machine learning, using AI, but it also is a part of automation in the end. And we can see here what we have is in the first block, so aggregation of the data. So we can try to aggregate this data. And as Michele mentioned before, with observability and with OpenTelemetry, it's also already giving to us a way to aggregate this data and also to correlate this data. The second part in the middle, we already discussed it before. We need the ML part or the AI to give us insight. So we want to be like better than before. We don't want to wait that there is the problem or that there will be an escalation. In this case, what will happen is that we will receive proactively an alarm. We will receive not only as an alarm, but also as we can start like a remediation at the end using automation. To identify the root cause analysis is really important. And in this case, sometimes it's really difficult because systems are becoming really complex. And in this case, if we want to kind of gain a bit of MTDR, so in this case, we need to be faster than before. And the last part is about predicting the issues. And now we are coming on the fact on the chaos engineering, because in this case, what we are going to do is to inject the failure and to inject failure inside the system and to try to understand if AIOps is working correctly. Not only working correctly, but because we wanted to replicate the same problem that we had in the past. And if you can see here on the right side, actually, the time before, we were always working in reactive mode. So we were waiting and then fixing the problem. We were waiting for the problem. We were kind of losing, let's say, the proactiveness. What you see on the upper part, so AIOps is bringing to us the possibility to have this proactive and even sometimes also the prediction. So the prediction is really complex in AIOps because we need to try to understand that we have a huge amount of data and we need to kind of deal with this data more or less in the real time. And the interesting is that it's not that this AIOps platform is giving us only insight, but is doing also the self-remediation. And you see in the last block is about driving action. So we can automatically self-healing, but if the self-healing is not working, so we need to use at the end one tool or another solution to kind of test this approach at the end. And then here is coming the connection to the next part. Michele, you can jump in the next slide. Yeah. So we start like from the scratch, from the beginning. So what is the chaos engineering? Because we mentioned at AIOps, we will use to get insight, but now in this case, we are going to have a view on chaos engineering. Can go next, Michele? I see only one part of the slide. Perfect. Okay, we remember already. So chaos engineering, so based on the Netflix definition, we are going to have this performing of a proactive experimentation on distributed system. And the systems are really complex. As I said, they are changing all the time. And why we need to use this? Because we want to build the confidence that the system is automatically repairing. So now if you connect this chaos engineering with the AIOps that we said before, we can use both of them together. And if you go in the next slide, Michele, please. Still not?
Yeah, there seems to be a bit of delay. Let me know when you can see it.
Not yet. No. And you can go also next, that is completing. So this we already remember. So chaos engineering model. So we start usually by the steady state posture. And Michele already mentioned we can use observability, but we can use also the other historical data. So we understand that the system is working correctly, everything is fine, and we have an offload at the end. Then we build the classical hypothesis, and we start the continuous verification. So on the lesson learned, I need to kind of bring what I experimented and what I found on the system. So an example will be like a blind spot. An example will be if we created noise at the end on alarming, then I need to kind of implement the remediation. And this is the last part. But actually it's not last because it will be continuously in cycle. And this continuous cycle is giving us the effect of the experimentation. Now, if you go next, Michele.
Yep.
And here we will see that the AIOps solution at the end is giving to us not only like the proactiveness of the failure injection, but we will see as well that the AIOps is bringing to us resiliency, robustness, and reliability. So it means that if we combine both together, So in this case, we are going to kind of experiment inside our AIOps system. And we need to find the best model and the best algorithm that is giving to us at the end the insight. Because this is the part of having chaos engineering and AIOps together at the end. You can go next. Okay, you can go on the demo, Michele. Thanks.
Thank you, Francesco. So what we introduced now, what Francesco introduced, is the concepts of AIOps and chaos engineering. But what we want to take a look now is a more practical example or a practical use case on how this actually works. And for that, we have prepared a custom demo. So yeah, so I will start with my Minikube environment where I'm monitoring around these 10 microservices that I see here. That are also relevant for our use case.
Now, yes.
Can you see it now?
Yes.
Yeah, so basically what I'm seeing here is these 10 microservices, which I'm using for this specific scope and for this use case. What I'm showing now here is a GitHub page, which is containing this environment for the online boutique store. This is a pretty handy page, in my opinion, a pretty handy GitHub project because you can use it if you need some environment to test or to do chaos engineering in. What we're seeing here is a microservices Kubernetes architecture, which contains all the main services that an average online web shop has. So we have front end, checkout service, ad service, shipping service. So basically, yeah, an average online web store. But okay, I suggest that we quickly move on to the observability tool. I hope it's real time, what I'm showing. I'll do a quick pause here and there just to make sure that we're synced.
Yes.
So what we're seeing here now is Splunk Observability, which we're using in this case as our observability platform. And here what I can see is the microservices architecture mapped into the APM part of Splunk. So I'm seeing all the different services which I have in my online web shop and the different errors which are showing the dependencies. What's pretty interesting, if you look at this red line, it's already showing me that there are some potential issues. And these red dots that we see, the bigger the red dot, the bigger is the failure that's underlying. So in this case, I'm having some issues with latency, and this is actually the purpose of this AIOps and observability tool. It's basically to tell us what the root cause is, because obviously maybe on front end, I have some issues. I have selected my order and now I want to check out, but there's some latency and I cannot finalize my checkout. So obviously there are some issues here on the front end. However, what Splunk Observability Cloud tells me is where is the underlying root cause error, which is in this case the payment service. Okay, let's now jump into Locust. So give me a second to see if. So Locust is an open source load balancing platform that we will use to simulate users. Specifically, we want to have a real life scenario. So we introduced already our microservices architecture, specifically our online web shop. But what we want to do now is basically start simulating real users. And you can imagine that there's users clicking around the website and different parts. So what happens now is if I go and edit here, I can specify the number of users as well as the spawn rate. And when I click start swarming, this will start generating users on my online web store. You can see here the different requests, the failures, and all the other metrics that come from it. And another thing that I would like to mention, on the top right corner, you can see the failure rate, which is 38%. This is important because later we will see that this will is increased as we introduce our chaos experiment. This is Chaos, Litmus Chaos. So this is another open source platform that we will be using for injecting our chaos experiment. But just to reiterate, what I want to do, going back to my observability platform, I want to inject a latency failure into my card service. So specifically, my goal is to inject some latency issues here and see how my AIOps and observability platform reacts. That is, if it's able to discover the error. So for that, I have created a very simple dashboard here, which is tracking the latency specifically for my card service. And if you look here specifically, I can also choose a time window. And I also want to quickly show you how we specified the alert conditions. So here I can specify between different conditions. In this case, I chose sudden change. And on the right-hand side, I have a hint saying it's useful for indicating unexpected increases in latency, although in reality, I could have used other options such as static threshold or historical anomaly. Okay, let's start the experiment. I want to initialize my workflow. So I schedule a workflow. I select the agent. Here, I can create a workflow based on a template, but in this case, I want to create a brand new workflow so I can show you how you do all the configurations. So I add a new experiment. And I hope you can see now, it's basically a set of different chaos experiments which I can conduct: pod delete, container kill, CPU hog, network loss. But in the end, what I want to do, as we mentioned, is introduce chaos experiment or latency issues into my card service. So I select pod network latency. And before we launch the experiment, a couple more configurations. So I need to specify my target, which in this case is, as we mentioned, the card service. In this case, we don't have any props, so we go next. And here I specify the duration of my chaos experiment. So how long do I want my chaos experiment to last? I specify 200, as well as the network latency, which I want to inject. Let's put 4,000 and click on finish. One thing which I suggest you do before you start the workflow is you basically select this option, enable cleanup chaos. This is quite helpful because it cleans up your environment after the chaos experiment is finalized. That way you avoid any misconfigurations that you might have from the chaos experiment. So I click next. I can schedule it at some time, but I, in this case, want to schedule it right now. And I go to check my workflow. And then I can see here that my chaos experiment is being initialized at the moment. If I jump to locust, I can already see that my error rate increased. It was 37 or something, so now it's already 60. So this is both due to the fact that I started swarming with a lot of users, as well as to the fact that we initialized already the chaos experiment. And I can see that my Splunk Observability Cloud tool already identified some failures. So this is specified by this red triangle that you see. But let me quickly check. I want to see if I received some alerts. Let me quickly read through my emails. And yeah, so here, if you look, I got an alert saying that the last 8 minutes is more than 3 deviations above the norm. And this is exactly what I'm talking about. Our AIOps observability tool managed to identify the issue, the latency issue, before it actually occurred. So if you look at the latency peak that I'm showing up right here, basically it's much higher, obviously, than the left-hand side, the trend of the latency on the left-hand side. And if you look at the point where my alert was triggered, it was actually several minutes before the latency increased, before this peak. And this is actually the point of what we're trying to achieve here. we don't want just to pinpoint the error. We want to predict it. We want to understand when it's happening beforehand so that we can alert the appropriate team so that they can apply some fixes before the issue go on. So in reality, we could also implement some level of self-healing, but for this scope, we will skip it. And basically, I want to confirm two different hypotheses. So the first one was, how does my AIOps solution or my AIOps platform react when there's some failure? As we saw, I got an alert which got triggered preemptively so that I have time to resolve the issue. The second hypothesis that we wanted to answer is my AIOps solution able to recognize when a chaos experiment is running? And as you can see, we built another really simple dashboard here, which is showing me the historical count of every time that the AIOps tool identified a chaos experiment. So as you can see in the last month in February, these are the days when I ran the experiment. So in conclusion, I want to say yes, our AIOps solution, our AIOps tool is able to predict and to understand when a chaos experiment is running. Okay, jumping back to our agenda. So I suggest we wrap things up. Today we talked about AIOps, chaos engineering, and observability, and we also explained how these three concepts are connected. Although the focus was on AIOps and chaos engineering, we also saw how observability can have a great effect and how this is an important aspect and concept that we need to implement before we start with any predictions or any experiments. So we have tested and confirmed a hypothesis today, which claims that AIOps can leverage observability in order to identify when a chaos experiment is running. Furthermore, this continuous cycle of hypothesis and experimentation, we iteratively increase trust in the system. And with every experiment, its reliability increases too. So the idea is we do it stepwise. So a final takeaway I would like to point out from today's session is start simple, scale fast. So you don't know where to start from. Well, perhaps start from a simple experiment, see how the system reacts, see how it goes. And as you proceed, you can scale and you can basically build more and more on top of that. So this is the approach that we wanted to point out for today. Okay, I think we're right on time. Thanks for watching and thanks for following this talk. I don't know, Prithvi, if we have time for some Q&A.
Absolutely. I think we can take a few questions and we can wrap it up quickly. We started off a little late. So I'll quickly display the questions that have come up. So I see a couple of similar questions. Which chaos tools out there have adhered to the AIOps concept? What are the tools that would fall under AIOps purview from a chaos engineering viewpoint? So this is the first question by Kumar Anshuman. Would you like to go ahead and answering the same?
Yeah, I will take this. So it depends at the end. So in this case, what we showed before is about we are using Splunk, and we are using the AI engine inside Splunk that's named IT Service Intelligence at the end. And for the chaos engineering, as you saw also from the video, from the demo from Michele, so we are using Litmus Chaos. So we are a big fan of Litmus Chaos. We already participated before in other event with Prithvi, with you, and so is our shoes. But why we choose this, as I mentioned also in the chat, I already answered it. We created a scorecard approach, and we kind of defined our showstopper in both sides for the AIOps tool and also from the chaos engineering point of view. And in this case, we figured out which one is in that particular scenario was working from correctly and was respecting what we wanted to achieve at the end.
All right, I think this also answers why did you choose Litmus Chaos for the demo? So that was a question from Mr. John Cash. I think the next question is from Behavior. While Open Telemetry is most used, what alternatives do you use? Do you see clients use?
Okay, depends. OpenTelemetry is helping us quite a lot because it's giving us a standard. And as mentioned, Michele was showing like in one slide, you can have only one agent. So before, when we needed to kind of get traces, we needed to have one agent. We needed to get logs, we needed to have another agent. And then imagine like for metrics, another agent again. In this case, using OpenTelemetry is one agent and will collect all of them. But not only on collection, also on the correlation. So it's faster than the others in the end. OpenTelemetry as in general, and as was showing like before, Michele is using Splunk Observability that is using at the end the OpenTelemetry agent. We achieved what you saw already on the demo.
Thank you so much, Francesco, for answering Javier. I think Javier has another question. When combining your OTel with OpenTelemetry with load performance testing projects, what other options you suggest to integrate with JMeter, Gatling, etc.?
Yeah, exactly. So this is a really good one because there was one slide, and I don't think that it was showing, but you have always this testing phase, so where you do a lot of performance testing, where you do a lot of load performance and so on. And in this case, you need also this data at the end. And as we mentioned before, you need to have a different set of data to kind of leverage AI that will kind of try to understand where is the problem, thus also to have the prediction. Not only on this, but also as I mentioned, to create a pattern. And if you have only one set of data, so only you you concentrate on the OpenTelemetry, but you don't have a JMeter data and so on, then in this case, you are missing one part. And maybe that tool is showing to you where is the problem at the end. Michele was also showing Locust. We use Locust for a lot of testing at the end, so you can test the API and so on. There are other tools, of course. We made it simple like for the demo today, but if you are interested, you can reach out us directly and schedule another demo at the end.
All right, thank you, Francesco. There's this last question from Ariel. There is a set of backends that allow viewing telemetry, metrics, logs, traces in OpenTelemetry, OpenSearch, Splunk, Prometheus, Grafana, and so on. What is the approach you are using to have a single backend in a unified way? All info.
Yeah, as this is also connected on the scorecard. So using scorecard, you can try to understand what are the showstopper. What are the showstopper at the end in this case when you want to choose the AIOps tool? At the end, you need to try to understand which problem you had in the past, and it's not that you are bringing just on a solution or a tool, but you need to kind of give it to the proper persona the tool that they can use. And in this case, as Michele was mentioning before with SRE and DevOps, is not only let's say using one backend. You can have multiple of them. The problem is that you need to avoid of jumping, so not jumping between different tools at the end, because jumping on different tool will burn for you the MTDD, MTDR at the end. And if you are already in SRE world, you're also removing a lot of error budget in the end. And this is what we wanted to optimize at the end.
And maybe one final note from my side before perhaps we close. So what we showed today is just one of the many demos that we did. So in case you're interested in general at the demos or at any topics, you can feel free to reach to us on LinkedIn, and we'll try to engage and help you as much as possible.
Absolutely, folks. Feel free to connect with Michele and Francesco on LinkedIn, and they have presented a great talk. Thank you so much for answering all the questions. Amazing questions coming in. You can add further questions on Slack, on chat, or you can reach out to them personally. And with this, we will end the session for today. Thank you so much. That was Chaos Engineering Meets AI Ops. Up next, we are having a session on Chaos Engineering enhancing application resiliency and security with Akash and Nilanjan from the Litmus community. Stay tuned. And thank you so much once again, Michele and Francesco. That's it from our side. Bye, everyone.
Thanks for having us. Bye.
Thanks. Bye.